The topic is about MetaController, and you can access this slide at this link. Meanwhile, a quick show of hands, like anyone who has built controllers, understand controllers? Okay, so very few. Not a problem. I'll try to make it really, really simple so that at least we go back home understanding some concepts, and maybe I'm not sure. I'm so sorry for that. Okay. And maybe apply it when we start using Kubernetes. So a bit about myself. I'm one of the maintainers of Project OpenEBS as well as the MetaController, the one that we are going to talk about. I work for MayaData, and I'm a remote engineer. I don't know how to navigate the traffic in Bangalore. That's what. And I will actually talk about my new home, and you will get to know about that in a few more slides. So this is about MayaData. So what we do essentially is we dig deep into Kubernetes. We try to extract the internals of how it works, what doesn't work, and try to fit that, that paradigm called Kubernetes into another paradigm that is infrastructure, of course, which is storage, the data. And we mix it up together, get the best pieces out, and we deliver it as the project OpenEBS. Again, OpenEBS is completely open source. It is as well as a CNCF sandbox project. You can find more about it, later on, or maybe you can talk about it. We can talk about it probably, throughout the day after this talk. All right. So this was the home I was talking about. Most of the times, you can find me here, asking questions or trying to solve the questions of the users, the community who has been using MetaController or in general controllers. Okay. So we have an agenda here, and there is only one agenda that I would be talking about here, and that is how to build Kubernetes controllers in a really, really simple way, without the baggage, without the steep learning curve that it has. Okay, so in order to understand, or in order to really get to that level where we can make use of the controllers, where we can build controllers really easy, we need to dig in a little bit deep into what exactly the control loops are. What exactly those jargons like reconciliation system, the control loops, the desired state, the observed state, last applied state. There's so many, and it's really difficult when you come from the other side of the world. When I say other side of the world, the kind of applications that we deal with typically makes use of APIs, right? The CRUD operations. But here it's a little bit different, okay? And that's where there is a mismatch, in what we have been doing so far in our applications versus what we need to do in Kubernetes so that these applications work or gel well, right? They work together. All right, the number one thing here, and again, like I said, we had to a little bit dig into the internals of Kubernetes, and I'll try to make it very simple. The first one is a client Go, which from the name itself says it's something related to Go and something related to client. So what exactly is a client, right? So it's a Kubernetes client that helps the Go developers, okay, to consume the APIs, or for example, the APIs are nothing but the Kubernetes resources, which can be native, okay, as well as can be custom. Native resources are something like pod deployment, STS, the ones which are built out of box or given to us by the Kubernetes. And the custom resources are the ones that we develop, right? That's the best way to extend Kubernetes. And again, a little bit facts about this client Go. We have to agree that this is being developed by some of the community members who have been active in the Kubernetes for a long, long time. I remember when I first started programming in Kubernetes couple of years ago, I guess it was 3.5 years ago, I was using a client Go, some version I don't remember, maybe it's 1.5 or 5.0.0, and I have never ever got an issue while upgrading this client Go libraries. So it is that efficient, it's that robust. Yeah. The second thing that we need to really understand is a CRD, okay? So what does it mean? So it is essentially a mechanism that Kubernetes provides right, to the end developers, okay, to define their own intents, right? Intent, right? What is an intent here? So it's a very nice mechanism where a developer, right, or a SRE or a DevOps admin, call it, you name it, you give a persona, but if they want to really make use of Kubernetes and if they find something missing in Kubernetes, which of course they will find so that it can adopt or adapt to their own requirements, you have to fit in with some scripts, some little bit of logic, some topping, some wrappers, right? And that's where Kubernetes CRDs comes into place. So you have a definition, right? This is called a CRDs, custom resource definition. There is an instance of the definition, which is known as custom resources. If you try to draw an analogy between the CRD and the CR with respect to the programming languages that we are most familiar with, for example, let's say I'll take example of Java, right? It has the concept of class and objects, right? Where object is an instance of the class, and the class is a blueprint, right? So you can think of that in a similar way. It's not exactly similar, but something very similar, right? Where Kubernetes is the underlying system. You replace Java with Kubernetes here. The definition is something you define a schema, some amount of schema, and Kubernetes just by the definition, just by applying the CRD to the Kubernetes, what do you get? You get so many things out of the box. Okay, what are they? You get a lot of CRUD APIs out of the box. You get the REST API endpoints, right? Without having to write a single line of code. You have the kubectl understand your own custom resources. You can do a kubectl get XYZ, blah, 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 and where blah, blah, blah is the name of your CR. Okay, and needless to say, these are the building blocks of the controllers that very shortly we'll be going ahead or we'll be talking about. All right, now we start digging. Okay, so before we go ahead, like I said, to understand how to build controllers in a really simple way, we need to understand the painful aspects of that, right? And I don't know how many of us are developers and who really code on a day-to-day basis, but a few of the slides ahead that we are going to see are a little bit about coding, and don't just fear about that. You don't even need to look at the slides. You can actually listen to what I'm trying to say, and let's hope it will be simple. Okay, so we need to have some kind of, when we try to design or implement a controller, there is obviously, you can divide it into multiple parts. I have tried to divide that the way I understand it. So the first part that I thought would be beneficial for all of us will be the startup logic, right? So the startup logic is the one where what we do is we try to configure the config of API server, the Kubernetes API server. Once that config is established, we have a way to create the client set. So what is the client set? Via a client set, we can make CRUD APIs. We can invoke, right? We can consume the APIs that the Kubernetes exposes. For example, we can do a get of a pod or a list of a pod, right? And similarly, the moment we try to, apply our custom resources, the same native client won't work. We have to have our own client. And here again, client Go helps us, via some code generation and so on and so forth. We get a new client set. The client says that is dedicated to our own custom resources. So for example, we can do a programmatic invocation of get blah, 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 where blah, 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 if you remember, is the name of the resource, the custom resource. Yeah, let's not go deep into this code. This is, kind of a startup code. This is the typical constructor code, and if you see, this is like the simplest one that I could ever make out, and I have actually copied that from the sample controller, the repo, which Kubernetes has in the GitHub. You can actually, Google it, and you can find it out. This is exactly the same. I have tried to, put it in a slide format. And here in the controller, this is nothing but creating the instance, right? Creating the instance where the controller consists of typically the informers, listers, even broadcasters and all, right? Like I said, I'm just giving out these terms, right, which are really, really hard to, to digest in the first attempt, maybe in the second and third attempt as well. But just for the sake of it, we need to just talk about it because in the forthcoming slides, we'll see that we will be eliminating all of these concepts away. All right. again, this is a concept that, the controllers, in the controllers we have to talk about, we have to queue the watch, okay? So if we have heard about the reconciliation systems or the control loops that Kubernetes is all about, there are two things, right? Two states rather. Okay, one is the observed state, the other one is the desired state. And whose state are we talking about? We are talking about the state of the resources. For example, the blah, blah, blah resource that we try to frame here in this session, that's a custom resource. And it can have an observed state, it can have a desired state, right? And all the loops, right? If you had attended the keynote session, what Dims was talking about, that circle, right? Diff, observed, and desired. That circle, that is where essentially boils down to writing the controllers. And watch is something like, it will watch your resource, okay? It will get the latest observed state of the resource to you, to your code. When I say code, to your hook or to your logic where you and I, we try to, do some, manipulations, do some customizations, and try to give back in return the desired state. All right, so this is, again, this is going to be a little bit interesting as well as a little bit, heavy. When we say we had queued the watch, now what about the desired state? Why do we queue the desired state? Yeah, we need to queue, sometimes what happens is, if you have created a custom resource, right, you want to have that custom resource generate some other resources, which may be native as well as custom. A point in example here is, if you consider the deployment, right, it can lead to creation of replica set, and then in turn the replica set creates one or more pods, right? So you have like observed state as your deployment and the desired state as the pods. And you can actually build one or more controllers to manage this desired state and reconcile to the observed state. Well, okay, I understand that this is getting really a little bit heavy with the code and all, but then this is the basic way that Kubernetes suggests us to, to understand in order to implement a controller using plain vanilla client Go, right? And then after all, once we set up the queues, we have the startup code, and then we set up the queues. Now comes the turn of the worker, where we actually, there are some terms like threads and all. We run these workers in a continuous loop, in a never-ending loop, so that they keep on watching, and whenever an event gets triggered, due to probably a change in the state of the resource, it captures that, gives it to your hook, and you try to do something, and you give it back as a desired state. All right, so when you capture that, you have to get it from the queue, and have all these methods which are known as sync and the sync is something like you get it from the queue, you unwrap that, okay, and the sync is actually the method or the function where you write your business logic, okay, and the business logic should be all about creating the desired state. You have to respond your desired state and nothing else. All right, I understand that we have been dealing with a lot of code, and it will definitely be getting really heavy and boring. But are we done? What do you think? Well, we had not done yet because we haven't yet written our business logic. It was all about dealing with the Kubernetes, the way the Kubernetes works, right? All about the sync, queue, the startup, all those set of things. All right, so again, like I said, this is the sample controller. In the sample controller, we have a resource called foo, right? We have an imaginary resource called foo, and when we apply the resource foo, we get a desired state. The desired state is the deployment, all right? So when we handle the business logic, we have to understand what is a foo. We have to, derive that. We have to get the foo. If the foo is really available or not, it may happen that the foo that we got as an event was a stale event. Which in turn means the foo might have been deleted already. Who knows that? So all those kind of things we have to understand, and we have to code it. And every controller that we write, right, each of them have to do this basic set of things. These are the common boilerplates, but then yes, you have to do it. There is no way out of it. Yeah, again, you have to code the desire. You have to see the desired and the observed. That is the actual state in the Kubernetes cluster matches. If it doesn't match, do something. Maybe you create another resource, delete the resource, or update the resource. Right? And like I said, what is idempotent here? So just try to understand you or when we write the code for the controller, we may be getting events. The events, the reason for these events, the root cause for these events may be different. Sometimes the event will be incoming when there is a new resource that gets created. At some other points of time, the event will be coming when there is no change at all, right? Because these are all periodic, the reconciliation systems, it's looping around and around. And obviously, there will be events that will come up when there are some updates happening. And one of the most trickiest case here is that the events can even happen when your controller goes into a restart, right? There are a lot of cases where the pod can get into a eviction mode, the controller restarts, and you get a deluge of all the events, all the old, new, everything, you get it. So you have to write the code in such a way that the code is idempotent. You have to make sure that the code returns only the desired state, okay? I'll be explaining the desired state a little bit later when we go to that logic, but but we need to essentially understand that desired state is very, very important, okay, when we write controllers, and that forms the basis of writing idempotent logic. All right, so to make it very simple, the desired state here in the sample controller is we want that particular structure of the deployment. And this is the deployment that should get in as a desired state, given a foo resource. Okay, now, are we really done? Like, it's really getting really, really heavy. The answer is yes, the controller's hardware is over. We are done with it, right? Now, okay, we have been talking all about these hardwares and all. Is there any really easy way that the agenda promised? And is it really possible? Okay, so this is our goal. We have nothing to do at all when we try to write controllers. That's my objective. I'll try to try to explain that in as much time I have left with me now. Okay, how can we do that? Is it even possible? That's the first question that we must be asking ourselves, right? Okay, so the first thing in MetaController is a CR. Okay. This CR is not the one that which is equivalent to your business CR, which is not your intent. This CR is something that MetaController understands. And if you see, right, so here is, this looks something like what you see is what you get, right? There is a parent, okay, there is a child. The parent is nothing but the foo resource. Now, this foo resource is the one which is your business CR. And there are something called child resources, right? The child resources are something called the desired. What do you want when you apply a foo resource? You want the deployments. So that goes the deployments, okay? And it's constructed or it's represented in such a way that you get to know, before even writing your code, you get to know what you intend to do with your controller. And this entire thing is, again, wrapped in as a YAML, which is a CR, that is only understood by MetaController. You don't need to write, code behind for this, okay? All right, this sounds kind of okay, but then what about the business logic, right? Okay, like again, like I said, yeah, we have a start code here, but just see the start code here, and if you remember the older startup code, do you find anything that talks about Kubernetes, right? Do you find anything called informers, watchers, even broadcasters, and queue, the threadiness, and so on and so forth? I don't think there is anything here. What you see is like a some kind of a structure which looks very similar to JSON. You grab whatever has been given to you as part of your those hooks, right? And you check if that particular here, I mean, what you grab is a deployment. You check if the deployment really belongs to the foo resource, right? Or it was just a standalone deployment. We never know, right? So if it really belongs to the foo deployment, and then you get the the replicas of that deployment and set it as a desired status. So what this code does is when you apply a foo resource, okay, a deployment gets created, okay, and the replicas of the deployment, the count of replicas of the deployment will be set against the status of the foo, okay. And And what you are seeing here is exactly that amount of code that you need to write. I have not tried to hide away some important stuff at all. What has fit into this slide is exactly the same amount of code that you need to write in your code. All right, and this is the desired state. So the first one was the config. The second one was the startup code. The third one is the desired state. And desired state is nothing but exactly the YAML that you intend, that you want, right? And what do we want? We want the deployment. And that's where. Okay, so that's, you can call it a JSON representation and so on. And okay, now are we done? Are we done with the, the building the controllers with whatever MetaController is supposed to do? Yes, the answer is yes. That was those 3 slides was all you needed to do to build an entire controller. And by the way, this controller is a sample controller that Kubernetes provides in the GitHub. And that if you want to do it using MetaController, you can do that. And you just needed 3 slides. At least I needed 3 slides. And of course, I used JavaScript. I did not use Go. No. Now, am I saying MetaController is, using MetaController, we can build controllers that were language agnostic, right? The answer is yes, again. Yeah, you can use any languages of your choice. Even there are users of MetaController who have used JSON.NET to build the controllers. Having said that, let's not just jump into the JSON.NET or all those fancy languages, right? It's all about what you need. If it's really, really simple, yeah, of course, you can go ahead with the JSON.NET. Otherwise, just stick to your competence. If it is Python, yeah, why not? Use a Python code to, to build your controllers. You don't have to learn Kubernetes for that, right? Because the MetaController abstracts away the Kubernetes entirely from you when you try to build your controllers. Okay, so that was about what MetaController can achieve in a language agnostic fashion, right? But then let us try to look a bit into deployment models of MetaController. One of the models that we can use is a shared model where MetaController runs as a pod, a single pod, and we can have multiple other pods, which in each of the pod they will have the controllers, right? These pods will be talking to the MetaController, all right? And each of these pods can observe or can watch their customer sources. That is, this is just one model. The second model is a shared nothing model where you don't share anything with, each controller is isolated, right? You have your own MetaController and you have your own controller, and then of course you have the CR. You can have everything boiled down to or wrapped in one container. So you can have one pod, one container, okay, and that particular container will be taking care of the controller needs of your customer source. It depends on you, so how you want to build it. All right, so we are getting to the end of this session. Now, what are the key takeaways? The best thing is you don't have to deal with Kubernetes. Kubernetes is dealt for you via the MetaController. So no informers, no listers, no watchers, no CRUD APIs. You don't need to do any client API calls at all. And of course, idempotent code is like really, really easy for you because all you need to do is construct the final state, the desired state. And if you do that and keep on sending the same thing again and again in your response, your code is idempotent. Again, so this is one of the very, very important aspects, the testing, right? 100% test coverage is always possible, okay? Because you don't have to, because there is no Kubernetes and all those informers, watchers, and all those stuff, you don't have to depend on the fake and the fake libraries and all. You don't have to write your code, your business logic in such a way that, you should be able to inject the mocks and all. You don't have to. You can just rely on your standard idiomatic, your own language unit testing pattern. And like I said, like we talked about, it is language agnostic. It is built on top of client Go. You can even, for those Golang libraries or for those Golang authors who want to implement their controllers using Golang, you can even import MetaController as a library. You just don't need to have like separate pods and separate containers running here and there. You can import that as a library. And because it is Golang, you can actually build a static binary out of it. And you can just push it, and it will be up and running. OK, so that is a little bit about the roadmap. we have been trying to push MetaController as a SIG project, as a, into Kubernetes so that it goes into the Kubernetes org itself in a GitHub Kubernetes -sig there. Just have a look at that particular link to get a little bit more details about that. All right, so yeah, I'm done. I guess I have even gone beyond my time. But any questions? Maybe you can ask me now, or maybe I'll be here the entire day. We can even talk. Any questions? Okay, no questions so far. I hope you will be able to understand some parts of it at least and give it a try. Thank you for listening. Thanks a lot.